Our next speaker is a very bright young man, and I'd like to bring to this stage Beth Beck from NASA to help set the stage and introduce him. Beth?
Good morning. I have the privilege, of introducing George. Oh, there it's on. I met George in April. We had our International Space Apps Challenge. I went to the New York event. George was on one of the teams as a student. And after the event, he came up to me and said, I really have this idea. I want to have this space apps for high school students. And so, because of that conversation we had last April, in August, he pulled off the first ever Space Apps High School, and he had hundreds there, and he'll tell you all about it, but I just wanted to be able to welcome him today after this awesome thing he did.
Thank you, Beth.
On the stage.
Okay, cool. Yeah, so excellent. So yeah, I'll be talking about Space Apps Next Gen, and then more broadly, open data in the universe, and how you can use open data to use for scientific discovery and to promote civilian science. Okay. So why is some high schooler speaking to you about data? That's a good question. And I'm gonna talk a little bit about what I've done. I'm probably one of the only people here that's not going to be involved in like civic data and that sort of thing, but I do a lot with science data. And so I'm actually going to read to you the first paragraph of my Common App, which is the essay I'll be applying to college with, which is incidentally about data. All right, so for fun, I help people in third world countries, bringing safe and potable water to those who need it. Sometimes I save civilian and soldier lives in Afghanistan or stop the spread of life-threatening diseases in hospitals. Instead of completing all my homework, I devise new ways to improve the process of hydrofracking, reducing resulting earthquakes and water contamination. Sometimes, if I'm in the mood, I'll even go back to moments just before the Big Bang and study how stars and dark matter reacted to form the largest bodies in the universe. But I'm not a super soldier, environmentalist, surgeon, or space telescope operator. I'm George Savolka, I'm a data analyst, and I'm utterly obsessed with using computers to solve real world problems. So that's me, and that's a little bit of what I've done, and I'm gonna go a little bit into each of those things and how data has empowered me to do science. Okay. All right, so yeah, brief overview. I think I mentioned this already. I'm just going to be going over the importance of scientific data, the hackathon model, about engaging people with that data, and then a few examples of what I've accomplished and what other people have blown me away with at Space Apps and Space Apps Next Gen. So when I talk about open data in the universe, I'm talking about the universe in a broad sense. And that's really ranging from all of science, from astrophysics, as people would normally associate with the universe, to epidemiology, which is the study of how diseases propagate and how transmission works. And so open data is fundamental to scientific discovery. Basically involving civilian scientists and how people, especially in 2015, how civilian scientists have been engaged with a lot of governmental agencies' missions, has helped push the boundaries of science by a wide margin. And right now there's more data than developers. There's huge numbers of untouched data sets, and 3,500 on nasa.data.gov alone. So one of the ways to get people excited in engaging this data is hackathons, the hackathon model, which you just heard a speech on this, but it's where a bunch of nerds get together to solve, to create apps and solve challenges. And so the hackathon that NASA threw, starting in 2012, was the International Space Apps Challenge. And then I'm just going to be going over a bit about what that accomplished and how Space Apps Next Gen, which was an event for minors in high school, mirrored that. So the premise was innovation through open data, and it was a worldwide event with like 133 locations online and 13,000 participants. It was the largest hackathon in the world. And the reason why hackathons are such a good model for engaging civilians and people around the world with that data is because it allows people across all walks of life, from storytellers and entrepreneurs to developers and software enthusiasts, to really approach that and work together in a collaborative way. And so one of the key things about Space Apps, and one of the things that we tried to mirror in Space Apps Next Gen, was creating an inclusive environment, a space that was open for all members, where all members could participate in data. And so those are some of the statistics. And we're happy to say that at Space Apps Next Gen, it was 51% girls. Yes, which is awesome. And we had 63% first-time coders. And Space Apps Next Gen was an event that was designed to help people learn and help people learn to code to engage with that data. And these are some of the tools and websites online that NASA has for people involved in the space apps and for any developers that are trying to get involved with it. So yeah, Space Apps Next Gen, which was the first governmental high school hackathon. It was focused on teaching people to code. And we had around 30 projects created with 150 kids and around 200 participants in the forms of judges and mentors come over the weekend. It was 24 hours. And this is a picture of the event. It was held in downtown Manhattan. And I'm happy to say that I've been working with a bunch of my friends and actually a bunch of adults in other cities, and we're going to be bringing Space Apps Next Gen to the world stage in 2016. So be hosting similar events to teach kids about code. So Chris Metcalf from, I'm going to be talking about a few examples of using data science and at Space Apps Next Gen. That's what the acronym is. And so one of the things that Socrata brought to Space Apps was the ability to they brought an awesome mentor, Chris, and the ability to basically use any of the NASA data sets. And one of the examples that Chris presented in one of his talks was the I like big bolides visualization. And basically bolides, they're meteors that are very, very bright in the sky, and he visualized the brightest 4 in the last I think it was like the last 5 years or so. You could see the one in Russia. And so that was just to get people started about engaging with data and to kind of approach to teach them how to approach data sets and visualize them in a different way. And I'm going to be talking about some of the results from Space Apps that were really awesome. One of them was Learn to Launch, which used NASA basically the requirements for rocket launches, and it taught the users, which were also kids, how to plan a rocket launch and engage them with that learning process. There was also SkyFind, which was a web app that you subscribed to, and then it would use the Twilio API to send you text when cool astronomical events were happening in your area, also using a NASA data set. Sun Decided, which also used NASA data, where you would basically take a picture of your skin. It would extract the color of your skin, and then it would use the data for like the UV levels and that sort of thing in your area based on your location to tell you what SPF of sunscreen you should use and how much you should apply on certain days, and it could notify you of that. Then some of our winners, or some of the ones that didn't win but were also super cool, was to see climate change, where they took a lot of NASA's climate change data and put it in visualizations of all sorts to kind of help educate the public about that. And then Mars, which took Curiosity, the Martian rover's height data, to create like an interactive type of game environment where kids could explore the actual Martian surface and where Curiosity was actually going. So that was awesome. And now I'm going to be talking a little bit about my research, about what I've done. So data can be used, like it's huge in the geophysics world. They have a lot of subsurface sensing technologies out there, and they'll scan large portions of the Earth, and then it will produce all this scattering data that no one really knows what they can do with or what's underground. And so by releasing that data, people can find hotspots and fault lines. And one of the things that I've started, sorry about that. One of the things that I've started to do was actually look at the data for where they went hydrofracking, and to find fault lines or underground aquifers using magnetotellurics data, which is a method of subsurface sensing, to kind of find areas where hydrofracking would be more prone to inducing seismicity or maybe polluting the water. And then to the right is one of the research projects I worked on with NASA, which was simulating an environment with a landmine, and then basically inducing radio currents into the ground and that from the air, and then being able to map out where landmines were across a wide community or wide area. And I'm happy to say that at the last conference I went to, that won an international award. So me and my mentor were happy about that. So, and then data can also be used in epidemiology. So this is an example of that web visualization I've made with Mount Sinai Medical Center, which is it's an urban hospital in Manhattan. And this basically showed how a fatal stomach disease, which is a huge problem in hospitals, called Clostridium difficile, transmitted from patient to caretaker to patient, and it allowed hospital administrators to actually select certain nodes and select certain groups of caretakers that were more prone to transmitting the disease, so that they could basically teach them to wash their hands and that sort of thing. To improve the sanitation standards there. And then data can also be used, and I use data for cosmology. And so basically in recent years, we've run a lot of simulations and a lot of different, we've taken a lot of cool data from space telescopes that has allowed us to create the world's largest simulation. My mentor actually was one of the people that did create it. And it was called the Illustre simulation, and it was of the universe. It was based on the background radiation of the galaxies of the universe, and then so they built this visualization, and basically it showed how the universe kind of came together over time to allow people to study dark matter. So they've released everything that happened in the Illustre simulation online, and it's open for people to engage with and discover trends with how dark matter created galaxy filaments and that sort of thing. So it can help us answer the big questions, which is really fun. Yeah, so thank you. This is a lightning talk. My name is George Savolka. I haven't really tweeted anything, but you could find me on Twitter at astro_civ. And then SpaceApps' Twitter is SpaceAppsNG. And you could learn more about SpaceApps on spaceappsnextgen.com and our live blog, which is bit.ly/New York City Next Gen. Thank you very much.